Thanks, Charles. Thanks, everybody, for coming out. I'm super excited to give this talk and tell you a little bit about why I decided to be a data scientist and how I use Kaggle to do it yourself, train myself to be a data scientist. So basically, I just want to tell you a little bit about how I went about turning myself into a data scientist, why I decided to do the do-it-yourself method, and why I decided to train myself with Kaggle problems. I also want to tell you a little bit about how a Kaggle competition actually works, and give you some strategy and tips for doing well at Kaggle. In the conclusions, to cover things. Was do-it-yourself data science actually a very good idea in the end? The pros and cons of training with Kaggle, and also some tips for interviewing, since I know ultimately most of you want to end up with a job. Actually, quick poll: who here is in school or studying or grad student? Okay, so that's like maybe a third of people. Cool. Okay. All right. So 8 years ago, oh my goodness, I can't believe 8 years ago now, I moved to the Netherlands to do a PhD in physics. My experiment was a bucket of glass beads, and I had a motor underneath that ran a disc, and the disc would jiggle the beads around, and they started to behave like a liquid. And this is really cool because I could get something heavy and drop it in, and it would sink, and something light would float, and the light thing would also float and jiggle around a little bit, and the jiggling around a little bit looked like Brownian motion. So that was the statistical and mechanical part of my PhD. And it's also why there's a rubber bath duck on the front cover of my PhD thesis and on my GitHub profile. I really liked my PhD. I really loved doing research. But I got to the end of my PhD and I thought, academia is kind of a pyramid scheme. And I looked at people who were a little bit ahead of me, and they are on the postdoc treadmill, their third postdoc, their fourth postdoc, and I thought, I would like to have a little bit more stability in my life than what 4 postdocs would afford. And I also wanted to have a little bit more control over where I wanted to live. And I knew during my PhD that I ultimately wanted to come back to Canada. So actually, I wanted to stay in the Netherlands a little bit longer because my partner was finishing his PhD. So in order to do this, I needed a job. And I had one criterion for a job, and it was that I would get more programming experience. So the first job that I applied for and got offered was a research position at the Dutch Cancer Institute. And it turns out the Dutch Cancer Institute, they basically hire PhDs in physics because they can do research and they can program. So I thought, great, I'll go and improve my programming skills. And then I discovered that it was all physicists who also had terrible programming skills. And there was no version control system. So I learned a lot of terrible habits. But I also learned a lot about anatomy in Dutch. The problem that I worked on was, so when somebody has radiation therapy, they make a 3D X-ray, a CT scan of the part of the person's body that's affected. And then every day that the person goes in for treatment, so when you get radiation therapy, you get radiation every weekday for about 5 to 7 weeks. And every day that you go in to have a little bit of radiation, they make another CT of your body. And then they use the position of your bones in the daily CT to match you up with the position of your bones in your planning CT, and then they know where to put the radiation. But somebody clever thought, oh, we can do a better job of delivering this radiation by taking the radiation dose and then warping it to look more like the anatomy of the daily CT. But to do this, you want to make sure you're doing a good job of doing that warping. So my job was to come up with methods for making sure the computer didn't screw up, basically. Anyway, so I decided when I moved back to Canada, I still actually didn't really know what I wanted to do. Just before I left the Netherlands, somebody said, oh, you should check out Kaggle, this website where you can do data analysis competitions. And I thought, oh, okay, what the hell? I looked at it, and when I saw the competitions that were running, I was like, wow, these are all really interesting problems. So one was optimize flight routes based on current weather and traffic. There was another one that was given samples from a pair of variables A and B, find whether A is a cause of B. Ooh, that's kind of an interesting problem. Predict Yelp business ratings. Recognize gestures in video and in video data, and identify bird species present in an audio recording. Okay, all these problems sounded really, really interesting. I had some ideas about how to approach them, not so many ideas about how to approach others. But the main thing was that I was curious. And once I sort of found this motivation, I was like, this is what I want to do. I want to work on Kaggle problems. So when I came back to this slide already. I want to do a quick poll here, because I know there are people here who are working as data scientists. So if you are working as a data scientist-ish, maybe you put your hand up. So there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so maybe 16. So of those, how many of you guys have computer science backgrounds? 1, 2, 3, 4, 5, 6, 7, 8. 8, so half have computer science backgrounds. Some, who has, sorry?
Should I fold this in?
No emergency. I think the numbers are small enough I can memorize them. Let's see. So who has a PhD in something or a master's-ish in something analytical? Chemistry, genetics, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Oh, this is terrible because I counted 16 first, and now I have 10 plus 8 is 18. Okay, this is going to not be very statistically significant. So another route that people use into data science is PhDs or postdocs in natural sciences, genetics, anything where you have some programming and stats experience. There's training programs that are mostly in the US. There's some in Europe. One example is Zipfian, Insight. Anyway, these programs, basically, it's competitive to get in, but then once you get in, you spend something like 6 to 8 weeks with a bunch of other people taking classes and making a little portfolio project. And then the thing that makes this nice is that the process is paid for by companies who want to hire data scientists. So when you finish the program, you have the undivided attention of many companies who would like to hire you. There's a lot of people who get into data science this way as well. But the disadvantage of that is that the programs are mostly in the US, and I wanted to try to live in Canada. And there's less competition for people with data science qualifications here. So companies they have their expectations is that they can just go out and find somebody. They don't have to go and train the person to come and work for them. Let's see. So I kind of did when I did be a data scientist, I sort of looked at the skills I had and then looked at the skills that I thought I needed to develop. And actually, as a physics PhD, I had a lot of skills that already kind of made transitioning to data science really easy. Math skills, linear algebra, calculus, solving optimization problems, time series analysis, Fourier transforms, and a little bit of statistics, very little bit of statistics, but some statistics. I had some pretty decent programming skills, so basically every time there was some sort of data analysis problem, or I had to get my experiment to run, or I wanted to just plot something, then I was using MATLAB, Maple, Mathematica, and if you can use any of those programs, you can learn how to program in Python. I also took a really good classes in undergrad it was programming for physicists. It was taught in Fortran, and we basically did a bunch of the numerical recipes from Fortran. We solved systems of linear equations, differential equations, a whole bunch of stuff that would be useful to you as a physicist, and actually turned out to be really awesome to have for data science as well. And also, as a person with a physics degree, you basically have a ton of experience at going and looking at data and saying, I wonder what's going on here. How do I represent this? And actually, I find that really useful too. The modeling aspect of physics is something that I definitely use now in my job. Now, the skills that I needed to develop, more statistics. I needed to learn all about machine learning. I needed to learn how to use some database tools, so SQL, and being able to use some cloud computing tools like Amazon Web Services. That's pretty handy. I needed to learn how to use a version control system because I didn't learn that at the hospital. And also, I just needed to get better at writing code that was going to be for an audience. So code that other people could read and understand. So I also thought about, okay, there's programs that have sort of started up to train people to be data scientists. And I thought about this, and I was like, you know, I've already done enough school. I've demonstrated that I'm awesome at getting degrees. I don't really need another degree. And I also realized, I thought about applying for some of these training programs like Zipfian and Insight. Then I realized I actually would prefer to try to stay in Canada. So that's definitely an option as well. Does anybody know who this guy is?
Yeah, but I might blow a gasket.
You might?
Yes.
Yes, okay, so this is Garrett Lisi. He's an interesting character. He has a physics PhD, and after he got his PhD, he was at some university in California where the weather is pleasant and the surfing is good, and he liked surfing. So he decided when he got his PhD that he wanted to keep doing physics, but he realized that most of the postdocs were in string theory, and he didn't really want to do string theory. So he just decided that he would move to Hawaii and live in a van and go surfing and do physics while his money lasted. And when I read about this guy, I was like, oh, you know, this is really cool. And I kind of realized, you know, I've spent my whole life mostly being in school. If I wasn't in school, I generally had a job. And I was like, you know, it's okay to be unemployed. This is a little hard to explain to my parents, but it was easier because, okay, so the only reason, I was unemployed for 2 years when I came back to Canada, and the only reason I got away with this was that Dutch PhD candidates are paid way better than Canadian PhD candidates, to the tune of like, depending on the dollar to the euro, but like 60 to like 100% better paid than Canadian PhD candidates. So I had enough money saved that I could pretty much do whatever I wanted for a little while. And once I saw that I could there were Kaggle problems that would give me a little bit of direction and focus and motivation, you know, that makes it a lot easier to get out of bed in the morning. So between the money and the motivation, I thought I can do this. I can be unemployed for a little while. Oh yeah, so my action plan when I came back to Canada, I arrived in, I guess, July of 2013, and I sort of planned out a series of little projects to help myself learn some new skills. So I wrote some little apps to request travel times from the Dutch Railway website and Google Maps and store the information in a SQL database. And I built a little app that would allow Dutch Railway users with passes for a fixed route to exploit some loopholes in their billing system. And I also started building a portfolio on GitHub. Now GitHub is usually used by companies or people doing like open source software to do version management, so that if you're working on some aspect of the code, you don't wreck other people's versions of the code. But they also let you just host a very simple website as well. So I started building a portfolio on GitHub. Into the future, I thought, okay, I'm going to do the Titanic problem on Kaggle. So Kaggle has a bunch of problems that are sort of billed as starter problems. The Titanic problem, you're given the data on who survived on the Titanic and like their gender, which class cabin they were traveling in, where did they embark from, and then you're given a subset of that data where you know who survived and who didn't. You're asked to predict who survived and who didn't in the remaining data. And it's just a way to get started with learning how to use machine learning. So that was sort of where I got started there. Then I thought, okay, once I've done that, I can tackle a real Kaggle problem. And then I had seen that the Coursera ran a machine learning class that was really highly regarded. So I'm like, okay, I'll do the Coursera class. This class turned out to be so interesting. I had no idea. I thought, oh, you know, the algorithms is going to be really dry and kind of boring, and I just really want to get to the data. But actually, like, learning about neural networks was really, really cool. I really enjoyed the class. So, okay, so what is Kaggle? Kaggle is a business whose clients are companies who have some sort of data analysis problem, and they can go to Kaggle, and Kaggle will turn their problem into a competition. And so Kaggle's clients are paying Kaggle to formulate their problem as a contest. Kagglers are just people on the internet who decide that they want to have a go at solving this problem. And so there's prizes for people who do really well, but and the prizes are substantial, but you have to be pretty good and also pretty lucky to win. So problems that Kaggle is good for. So I should probably start off by saying that a lot of data science in like data science work is exploratory. You want to just sort of you have some data and you want to go and look for patterns in that data. And Kaggle only works for data where you have labeled data, where you want to make a prediction and you have some way to test whether your prediction is correct. A lot of data scientists also work on problems that are more like A/B testing. So that's like if I have two populations, or if I have a population and I give half that population one treatment, so they, for example, you have users they go to a website and the text is red, and you want to see how many people buy stuff on that version of the website. And you have another version of the website where the text is blue, and you want to see how many people buy stuff when they get the blue web page. That's A/B testing. But Kaggle doesn't help you do that. It's really only for problems where you have to make a prediction and there's a way to see if the prediction is true. So the problems that Kaggle is good for are regression problems, classification problems, predicting elements in a time series, and labeling segments in a time series. And actually, I'm going to group these a little bit differently because, yeah, the way Kaggle has evolved in a slightly interesting way. There's a class of problems which are, I call feature building problems, where the features don't have the same units. And so let's see, in this case here, okay, so in this case here, you have things like in the bot versus human competition, which I'm going to talk about more later. You have information about what people have bid on in an online auction. So you have information like what IP were they visiting from, how often do they bid in an auction, what's the time between bids in an auction, and all those things that you can measure are different units. Whereas if you have a problem where you have, for example, you're classifying images, then you have image 1, and you have one data element, which is the value of pixel 1, another data element, which is value of pixel 2, pixel 3, and all the information is the same type. And I think actually that makes the problems more suited to a neural network approach. All right, so how to learn with Kaggle. Starting with one of the learning problems is usually a good idea. These are all flagged on their website. I've talked a little bit about the Titanic problem. Another tip is to pick a problem with a small amount of data, because that just makes it easier to manipulate. And I also recommend, when you're starting, pick a problem that's been going for a little while, because then if there's something funky about the way the competition was set up, people have usually figured it out by then. And occasionally it happens that there's something a little bit strange about something in the competition, and then people work that out eventually. Another piece of advice is look at old competitions and read the forums, and especially people have been able to share their strategies. The people who've done really well will often do a little write-up about what they did that worked really well for them. And you can learn a lot just by reading about what other people have done. People also, while a competition is running, people also post starter code. So this is just some quick and dirty script to usually load the data, run some sort of simple classifier, and write out the prediction. This is not always high quality code, but at least it's something to just get the data in and then make a prediction. And it's useful to see how other people set up their code. And you can use that as a starting point to build your own empire on top of what their foundation looks like. Okay, so Kaggle is a competition because during the competition, there's a public leaderboard. And so what happens is you're given some training data and the labels for the training data, and then you're given some test data and you're asked to make predictions for this. And while the competition is running, the public leaderboard consists of your predictions, but only about 30% of those predictions that you made are actually evaluated. And so you can see how you're doing relative to other people, but you don't know what the final score is going to look like until the competition is over. And then you see the private leaderboard, and all of your predictions are scored at that point. So that's what makes it exciting, because you can see how you're doing relative to other people, but you don't know what the final result's going to look like. Question?
They don't actually have a third data set?
So the question was, there's only two data sets. There's a There's a training data set that has the labels, and then there's the test data set that doesn't have the labels.
No, there's the third, which is their set that you upload for the actual test one, right?
Okay, so what you get is X-train and Y-train, then and you are asked to make predictions on X test, and you don't know what the values are. Yes, you have to split this yourself if you want to do cross-validation. That's another slide. It may be the next slide, actually. Nope, it's not. Okay. Okay, so one of the problem that I actually did really well at was the bot versus human competition. So I'm going to talk a little bit about feature engineering and strategy with respect to this particular problem. Kaggle problems are all really different, so it's actually sort of hard to generalize to say the strategy is what I always use for every single Kaggle problem and it never lets me down, because really every problem is a little bit different. So in this competition, you have you're asked to look at bidding data for an online auction, bidding data. And so you have information like what auction the person was bidding in, when did they make the bid, what IP did they place the bid from, what was the referring URL hashed. And then with that information, you're asked to identify whether a particular account belongs to a person or belongs to a robot. Okay, so they give you some data. There's a train.csv file, a sample submission file that shows you what format you're supposed to be submitting your predictions in, the test data CSV file, and then there's this other bids.csv file. So actually what they have here is there's this X-train and X-test, and you're given the labels Y-train, so this is bot or human, and then you have these events, which are actually just the bids. And the challenge here is actually to take these events and map them into X-train. So you actually have to build X-train yourself. And this is what makes the competition a feature building competition.
So sorry, what's the difference then between train.csv and...
Okay, so they give you some training data, which could be, I haven't actually looked at the data for a really long time. So there was some information they had about the user that didn't change, that was the same for every bid that they made, and that just went into X-train.
So it's like profile information.
Yeah.
They're in this location.
Even the location information was in the events thing, because people can move around when they bid, too.
Did you have to join the two data sets?
Yeah, well, that's the magical operation that happens in my head.
We have mics that we'll bring around to questions. Ask lots of questions, but just please hang on 1 second to get
I was
back.
just asking if you had to join the data sets.
Okay, so it's not, taking events data and mapping it into X-train and X-test is not as simple as doing a join. So maybe I actually just move ahead to that. Here we go. Let's look at this slide. X is this matrix where each user is a row, and then you have properties of this user. So when you downloaded the training data, they gave you X-train here, but then you actually have to add additional columns to X-train by examining the event behavior. So basically, every time a user makes a bid, so for example, user 0 makes more than one bid, there's some behavior that you have to make some sort of aggregate description of their bidding behavior, so you can put that as a feature into this matrix. Is that clear? Okay. So here I did actually write down what the columns were in this event matrix. It's bid ID, bidder ID, the auction, merchandise, the type of merchandise that they were buying, their device that they were using to connect with, the time, the country, the IP, and the referring URL. So how do I actually go about feature building? Usually I just start by exploring the data and make lots of plots. And you look at the data and you think, oh yeah, I totally know what's going on. It's not really till you make a plot that you can sort of make sure that your picture of what you think is happening is actually what's going on. So my first idea was actually to look at bidding strategy at the end of an auction versus bidding strategy at the beginning of an auction. Because I know that some people snipe an auction right in the last millisecond of the auction. They're firing off a bid, and I thought, okay, I can probably use this to describe whether they're a bot or not. But the thing what I actually discovered when I made this plot, so I made this plot here of this is a histogram of the bids over time, And I discovered there was actually 3 clumps of bidding activity and then gaps of nothing. And then, well, in further inspection, I thought, okay, probably whatever bidding activity there is going to have a periodicity of 1 day, just because 1 day. So I could indeed see this nice periodicity here. So this was like 3 days. And then there was a gap of 11 days, and then like 3 more days of bidding activity, and then another gap of 11 days. So the thing I realized when I made this plot is I couldn't use any information about bidding strategy because I didn't have actually any information about whether I knew an auction was over or when I knew when an auction had started. There was no way for me to figure out where in the auction the bid had been made. So I couldn't use that as a feature anymore. But so what I did do to start with was just to go and look at the bidding activity for one auction. So I've done my little pandas query. I ask to look only at bids in this one auction here. And the first thing I noticed was that there's this character here, 965CC7, who seems to be a very, 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 very busy bidder. So one thing I realized right from the start was I can use the number of times that a person bids in an auction and the median time between their bids. These are all features that I can use. And so the cool thing about machine learning is that you can make up whatever features you think are interesting, and the algorithm will go in and figure out whether which features are actually instructive. So this rewards being very creative. And you can be a bit stupid, but as long as you're creative and come up with something that's interesting and useful, then the algorithm will pick out what's useful. So I had the features that I made up were things like median bids per auction, median time between a user's bid and the previous bid in a different auction or in the same auction, the time between bids made on different IPs in the same auction or in a different auction, is a user active on an IP which is known to have bot activity. And then this is really interesting. So my PhD involves statistical physics, and there's this interesting quantity called entropy, which is basically how ordered is a system. And I realized that actually entropy can be used to describe somebody's bidding behavior. If somebody places all their bids from the same IP, that's very ordered. If somebody places bids from a bunch of different IPs, that's more disordered. So I can use entropy to describe the bidding activity. There's no stopping at just the IP. I can calculate the entropy for the URL or the day of the week. And weirdly, it sometimes helps to take the log of whatever values you're generating. I haven't totally understood actually why this helps. I think sometimes that if you are looking like something like at the standard deviation of something, and you don't have something that's a Gaussian distribution, you often have something with a tail, and then just taking the log helps to sort of normalize that tail away. But yeah, sometimes taking the log just...
You're linearizing data.
There's a mic on the, pass the mic to Tommy, please.
On? Is it on? It'll also, like, if it's something like a Gaussian curve, it'll linearize the data. So you're putting things that would be on like a curved scale onto a linear scale, which makes it easier for certain algorithms to pick up on stuff.
Okay, well, whatever the magic is, it for whatever reason works. And we may arrive at a more profound understanding over drinks tonight.
Another question.
Question?
Just
Just
come
before
get
you,
closer to the mic.
oh sure, just before you transition away from feature building, are you limited to data that are available in the test set, or could you say maybe you think that Tuesday is a big purchasing day in countries with a certain GDP? Could you go and do additional research to build it in?
Yeah, you could. Usually the competition, they'll say whether or not they want you to use outside data. Usually they'll specify whether it's allowed or not. In this case, I don't think it would have helped you very much. My suspicion is that they cut the reason they threw out chunks of the data was they wanted to use only weekday information, and like things like in different countries, different days are holidays, different days of the week are holidays, and also it was you could definitely. There's nothing stopping you from going and trying to make something out of that if that was something you think is useful. Okay, so once you've got your nice features built, the next part of the strategy is to pick an algorithm. And so one of the nice things about scikit-learn, which is the machine learning package for Python is that they have this handy flow chart that helps you make a good decision about what algorithm to pick. But especially for classification problems, I've actually mostly just started using gradient boosting machines and random forest classifier, just because they usually work pretty well, they have fewer parameters to tune. So it's easier just to shove your data in and get something out that's half decent without having to worry about tuning learning rates or mysterious normalization parameters. That's the hot tip of the day, I guess. So when you're doing a competition, one of the things you actually have to work out is how good is your prediction. And the way to approach this is to construct a cross-validation set from your training set. So basically what you do is you break the training data into two segments. Usually 80% you turn into another training set, and then the other 20% you turn into your cross-validation set. Then you use your algorithm to train on this data, and check your prediction with the predictions here, and then you make a prediction for the cross-validation data and see actually how well your algorithm performs. And usually what you do is you make the split a couple different times, and then check to see how the algorithm performs on each time you split it. And the reason this is useful is it actually gives you some idea of what score you can expect on the leaderboard. And before the competition ends, you have to pick your two best submissions, or what you think are going to be your two best submissions. And if you have an idea of which submissions you think are going to be the best, then it's easier to make your picks about which ones you're going to use. You have some feedback from the public leaderboard about how you're doing relative to other people, but you don't always want to overfit to the leaderboard. If you want to make sure that you think you're doing a decent job of making a prediction. So usually I try to pick a prediction that's one prediction that I think is going to do really well based off of the cross-validation scores I have and also the leaderboard score. And then I make a second, more conservative pick. And one of the things actually that shows up every once in a while in a Kaggle competition is that the training data can be a little bit, this slide. The training data may not always overlap with the test data. So you might have the situation where your test population is actually a little bit distinct from your training population. So in this case, using the leaderboard as a bit of a hint for whether or not your algorithm is going to do well is actually helpful. I kind of realized that one way to determine whether you're going to have this situation is to train a classifier to see if you can distinguish between the training and the testing population. That's my little trick. Another thing to keep in mind is that when you have this situation is that near neighbor algorithms are better at interpolating than extrapolating. So if you have a situation where you have to extrapolate and you're using a near neighbor algorithm, you have to be a little bit careful about trusting your predictions. So in this case, actually, I can recommend this package called Stats Models, which lets you exploit some underlying distribution that the data conforms to. So if you have data about some part of the distribution and then you know that you can extrapolate on like a Gaussian, then that allows you to do extrapolation. Okay, so more general strategy. Just start by building something simple that makes predictions and does cross-validation and writes the predictions to a file. Question?
There's a mic on the couch next to you there.
Do you actually have access to a cluster of machines? Or are you just using one machine?
Okay, so actually when I started, I had a 4-year-old laptop, which was pretty awesome for the most part. And after a year of basically spending like 8 hours a day on Kaggle, I was like, okay, I need a better computer. So I went and I bought a MacBook, and that's what I was using. Now that I'm doing more problems with neural networks, I've been buying time on Amazon Web Services. But I think actually I got a little bit tired of being booted off constantly, and I think I might build myself a little GPU that's not going to be used to play computer games.
I see. But, so you're trying to say that the data is actually small enough to fit into main memory?
It's actually fairly common that it will all fit in memory. Most of the competitions that I've worked on that haven't been sort of neural network orientated, the data is, definitely been like in the megabytes range even.
Do you have any experience with Hadoop?
I have no experience with Hadoop, but I would sure like some.
I see.
Okay.
I guess you. What I'm gonna say last is that to actually justify using Hadoop, you must have a lot of data.
Yeah, I
Like-
think
like
that's pretty much what the
maybe
case is.
Like between like 1 to 5 terabytes or even more than that.
Yeah, so Hadoop is like databases for really huge amounts of data. And Kaggle competitions are usually geared towards much smaller amounts of data. Thanks. Okay, so I already kind of alluded to this, but keep track of your cross-validation scores. So usually what I'm doing, once I have a kind of a basic script going, I actually have a little lab notebook where I keep track of what I've changed in the code, and then the cross-validation scores that I've generated. And then just to avoid doing anything really stupid, I save the script that I used for each submission. Once you have something working, then that's the time to start investing more energy in feature engineering, and maybe also fiddling with the algorithm that you're using, the parameters of the algorithm. And I guess the final tip, if you really want to just win something, recruiting competitions seem to be a lot easier and less competitive. Both the two competitions that I've done really well at have both been recruiting competitions, and I think this is just because there's no money involved. It's just getting an interview. And people who are doing really well, that's not necessarily motivating for them.
Slash your screen.
Oh, okay. I'm going to have to go over here and let's see about this. Oh. It says no signal. Shall I plug it in and unplug it?
Yeah, try that. Reboot. I think that's working.
Okay, oh, look at that. Victory is mine. Yes, the final tip is if it doesn't work, unplug it and plug it in again. Was there?
Ask you to clarify the notebooks. Do you use IPython notebooks for different, or what was the notebook?
All right, I actually, I have a little file in Text Wrangler where I literally put in like, I just changed this thing so that I can, and then I changed this other thing, and then I cross-validate like 10 times or something like that and report the cross-validation statistics. It's very unsophisticated. Well, let's see. Okay, hold on. I might have to go and wave my hands over here again. There's the mouse, and we're full screen. That's great. Yay, victory. Okay. Who wins at Kaggle? Well, as you may be surprised to hear that smart people who spend a lot of time on Kaggle. It actually includes a lot of grad students, people with university positions who are kind of free to figure out what to do with their time. There's actually quite a few consultants who seem to be dividing their time between Kaggle and industry projects. So they Kaggle for a little bit and then they go and they do a paying job. And I think, I don't know, a lot of these people seem to have gotten their start on Kaggle and then just kind of made consulting into their business. There's also a lot of people who've already made a pile of money in a startup, and then they're just looking for a meaningful way to spend their time. Kaggle actually started interviewing people who've done well at the competitions, and this is sort of interesting sometimes to read about the backgrounds of people who've done really well. Let's see, the other interesting thing is if you look at the breakdown, so this is actually data that I looked at in July. I looked at who are the top 100 Kagglers and where are they from? And the first thing that I noticed was there are a lot of people with Dutch names on the top 100. And then I boiled it down a little bit more, and I looked at the Netherlands actually has the highest per capita number of top 100 Kagglers of all the countries that are on Kaggle. Canada, I think there is 2 at that time. And the US, Russia, and Japan have a lot of people, but they also have, the countries also have a fairly large population. I don't know, maybe this is not super statistically significant, but I don't know. Having just come from 6 years in the Netherlands, I had some ideas about why this might be. And I think it's the answer to the question, why are Dutch people so good at Kaggle, is actually related to the question about why are Dutch people so good at speed skating. And I think actually the answer is that, the answer is that they're also really good at this sport, which you do with 2 wheels. The answer is basically cross-training. The more problems you do, the better you get at approaching a new problem. And Dutch people also have a huge amount of vacation time. Like, I had 6 weeks of vacation as a postdoc. I cannot take 6 weeks of vacation. I can do like 4 weeks. I can totally take 4 weeks of vacation. But and a lot of people actually work a reduced work week as well. So that means that people they don't work 50 hours a week at their job. They work a civilized amount, and then they have time to go and Kaggle when they get home in the evening. And that creates a huge opportunity for learning and training. And I think that's one of the reasons why that there are a lot of top 100 Dutch Kagglers. So I also want to say that I didn't do it myself, data science by myself. I had a lot of help, mainly from these 3 people. Bruce, who I went to undergrad with, who decided to go back and do a master's in machine learning in natural language processing, and he's really good at math. So anytime I had anything to talk about natural language processing or just math, he was always there to chat about that. My friend Nick, he worked at a startup, and he had lots of advice for talking to startup, and he also, thanks to his astronomy PhD, knew how to use Amazon Web Service. So he actually tutored me in how to use Amazon Web Services. And then Philip, who I actually live with, he taught me how to use GitHub and resolved much of my frustration involving installing Python packages, which is still the thing I hate most about programming, installing packages. So advantages of do-it-yourself training with Kaggle. I think Kaggle problems are really interesting. So just having that motivation, that was really the best thing about it. Kaggle also provides starter code. People on the message board give suggestions for methods, insights into the data. They ask good questions. It's a really good way to learn by reading the forum. Because Kaggle only rewards accuracy, and to some extent being helpful in the forums, it's a no bias environment. So I can be out there with my little icon, which is a duck, and people will not know that I'm female. Obviously, I'm standing here, I'm female. But when you're on the internet, you can be totally anonymous, and I really appreciated that. It gave me a lot of confidence to know that people were only responding to my ideas. Kaggle gives you a benchmark for your skills, and it also gives a potential employer a benchmark for your skills. And I think a lot of confidence comes from knowing how you're performing relative to other people. Kaggling lets you build a portfolio. So every time I did a competition, I would write up what I did, what my strategy was, and I would put it on my little GitHub page. And that was something that I could put in resumes when I sent them around, like, here's my portfolio. Kaggle problems also give you something to talk about when you're networking. And okay, I think many people, including me, find networking kind of awkward, but if you have something that you can talk about that you're interested in and that you think that will be interesting to other people, that actually makes networking a lot easier. And finally, Kaggle actually gave me freedom to travel. If I had been in a degree program, I would have had to stay in Vancouver, but I was able to spend some time in San Francisco, and I was able to go to Brazil for 6 weeks, and that was really cool. And when I Kaggled while I was in San Francisco, and I Kaggled while I was in Brazil, and I Kaggled while I was in Vancouver. And it was nice to have that freedom. Disadvantages of training with Kaggle. So Kaggle actually does a lot of the hard work of data science for you. When you go to Kaggle and you download the data, they've already gone to the trouble of making a nice labeled data set. And honestly, a lot of data science is actually just getting the data, cleaning the data, making sure the data is labeled, trying to get data that you can actually label. That tends to be most of the problem in data science in a real company. The flip side of Kaggle only rewarding accuracy is that there's no points for like making a nice visualization or even putting error bars on your prediction, all which are very valuable things to know.
Can I ask a question there, Steve?
Sure.
I can probably talk about it.
No, use the mic, please. We're recording.
Is it over there?
So I was just curious, do they ever have requirements for like prediction time or anything like that like you would see in like a real company, right? Like, are there any things like that, or it's just upload the CSV?
If you can make the prediction before the competition ends, you can submit it. Yeah, the reality is that it has to be somewhat reasonable because you probably want to make more than one prediction.
What's the time
Usually, okay, so how long is the competition? And usually they're about at least 2 months long. And some competitions that are run just for like learning, it'll be like 9 months even. Was there a question over here too?
How much time do you spend on a particular Kaggle problem?
Okay, probably way more time than I should. I find Kaggle really addictive. I love to spend time on Kaggle. I was kind of treating it as a day job. So generally, when I was unemployed, I would Kaggle for like 8 hours a day, maybe 12 to 14 hours a day if the problem's getting really interesting. But I generally would not work on the weekend, and I have a full social life too. So, yeah. Another question? Yeah, let's just grab it here.
Or Mark's got it.
Hi, I was just wondering, how much statistics do you need to have for these?
I would say 0, because there's no statistics involved. It's the only statistic you really need is making a decision about which of your predictions do you think is the best. And if you can understand, I need to split my data 80-20 and do cross-validation a couple times, that's about all the statistics you really need to do to. It's really more about machine learning. There's another question?
Hi, I was curious, how do the leaderboard scores change as you approach the deadline for the competition? Do they start jumping quite a bit?
Well, okay, so different competitions are interesting. Sometimes the scores jump around quite a bit, and that's usually a case where the test set is quite different from the training set. So there was this one competition, the Africa Soil Prediction Challenge. They gave you satellite imagery data for different soils, a bunch of information about the soil, and you had to predict certain nutrient contents. And what they'd done when they packaged the training data and the test data was they'd taken soil samples from a bunch of different locations, and then the test data was soil samples from a bunch of different locations. So it was you actually kind of had to, the populations were separate. And that, there's a difference between doing that and taking some data from this sample, some data from this sample, and some data from this sample, because that's a problem that you're going to be doing a better job at interpolating with. So in that case, then the leaderboard scores can move around quite a lot. Sometimes people also they get tempted to overfit to the leaderboard, and in that case, people's scores can drop quite substantially. It just usually means that they did a bad job of using cross-validation to try to pick out which of their predictions they thought was the best. Another question?
Why don't you take,
Where's the company headquartered?
Where is Kaggle located?
Yeah.
In San Francisco. There was another question behind you, I think, too. You?
She had the mic.
Oh, you had the mic. Okay. One more question over here.
Hold on 1 second.
So I have a question on how you decide about the features. So you have the all test data, and then you have some data for validation, and you run the algorithm on some of them. So when you want to decide about the features, do you use the whole data of whole test data, or you use the part that you want to train the algorithm on? And then, do you know?
The way I think I understand your question is, how do I decide which features to use?
Yeah, and what part of data do you use to make that decision?
Okay, so the answer is I use all the features. So the cool thing about machine learning is that it will go in and figure out which of those features are the ones that are helpful for making the prediction.
Question is, do you so you have validation data and you have training data?
Okay, yeah. So when I do the cross validation, I split the data. Usually it's a random split. So basically, I just take the training data and randomly pick 80% of that to be my training set, and then 20% of that to be the validation set. And then I make that split several times. So I'll go in and more than like 5 to 10 times split the data 80-20 and then train on the 80% and test on the other 20%. Sometimes you can't do that though. Sometimes if you have time series data, so there's this Walmart sales prediction competition, they gave you 3 years worth of sales data. And so really when you are doing cross-validation, you want to be able to take, ideally you would have 1 year if you had 5 years of data, then you could use 1 year as your validation set and 4 years as your training set. And then just do that 5 times, each time have a different year as your validation set. Yeah, sometimes it's not so easy to figure out how to split it in a way that's actually giving you information that you can use. One more question?
Hi, yeah. So do you have any tips on building ensembles after you've done all of your feature engineering?
Okay, so I've only actually tried that once, and it didn't provide any value. I think I can track down some information for you, but I'd have to look at my computer to do that. There are people who've done it quite successfully, though. So the strategy he's asking about is you can actually use more than one machine learning tool to make a prediction, and then you combine all those predictions together, and usually what happens is you get a better prediction out than you would have gotten from any one of the predictions you made with any one single machine learning algorithm. And this is called ensembling.
Gradient boosting is ensembling.
And gradient boosting is ensembling. Let's see. So yeah, so a lot of data science jobs are primarily statistics with a little machine learning. If you're working at a company that's like, how do I get people to click on stuff to buy stuff on the internet? That's mostly A/B testing. It's less about the machine learning side of things. And Kaggle doesn't help you learn to do statistics or experimental design. You have to actually take a statistics class to do that. And Kaggle is a winner-take-all economy, so there's great prizes for people who win, but everybody else gets nothing. Disadvantages of do-it-yourself data science. I already sort of said this, but Kaggle is pretty addictive and can be kind of a time suck. A degree forces you to learn things that are good for you. I'm sure that when I was an undergrad, I probably wouldn't have taken linear algebra, but then it turned out to be useful in things like quantum mechanics and machine learning, so I'm glad that I did take it. But when you're doing a do-it-yourself program, you have to be kind of careful that you're pursuing your interest, but at the same time forcing yourself to learn things that are good for you, and just being aware of what it is that you're missing also. A degree or a training program like Zipfian or Insight, that also provides you with sort of a route to a job, a route to an internship. And I didn't have that option with the do-it-yourself program. So I had to work really hard to make contacts, to network, and to get interviews. And I think that would have been easier if I'd been in a degree program. And yeah, just being unemployed is kind of hard. It's kind of hard looking at your bank account balance dwindling, and my parents are like, generally very laid back people, but then they're like, oh, what's wrong with you? You are a smart girl. You don't have a job. That's really hard. I'm glad I stuck with it, though. I like the autonomy, and being able to do interesting things, that was worth it for me. Okay, so action plan revisited. So I had this sort of 6-month plan where I was going to teach myself SQL and do the Titanic problem and tackle a Kaggle problem and do the machine learning class on Coursera. And then sort of at the end of 6 to 9 months, I thought, oh, somebody would surely realize my brilliance and offer me a job. But it didn't quite work out that way. In fact, I was unemployed for about 2 years. And I have to say, I think it took me a year to get good at data science. But after that year, I spent most of my Kaggle time focusing on problems that where I would have to use neural networks, just because I thought that was just super interesting. But after a year, my Kaggle scores stopped increasing substantially, and I thought, okay, I'm not learning as much as I was learning when I started. Okay, so probably what everybody wants to know here is, does doing well at Kaggle help you get a job? And well, it's kind of yes and no. The company, it turns out, my experience has been that companies don't really care if you are decent at Kaggle, but they do like seeing a resume with a big unicorn sticker on it. And if you have Kaggle Master on your resume, that's a big unicorn sticker. I definitely saw job advertisements where people asked for Kaggle experience, or at least suggested that it was going to be valuable. But I also had the experience in Vancouver where 50% of the HR that I spoke with, or the recruiters, they had no idea what Kaggle was. So in that case, it's not helping you to get your foot in the door if the HR people don't know what Kaggle is. my experience has also been that if companies don't really care if you're smart or creative or can take initiative. They only care that you've solved almost their exact same problem at another company. Companies can be really conservative, and I'm not really sure how to persuade companies to take risks on people who might be awesome, or even to explain to companies that, if I'm good at these 5 different kinds of Kaggle problems, then I'm probably going to be good at this other kind of Kaggle problem. That's something just that we have to educate. When we do have jobs, we have to educate the HR people at our companies about that. I had actually generally pretty good luck with getting interviews at small companies. For whatever reason, I just did not figure out the magic recipe to get interviewed at large companies, so most of my interview experience is at small companies. And what I've actually found is that small companies, especially where they don't have a data science person, they don't actually really know always what they want or need. And okay, this is okay. It's a hard problem actually to know when you don't have this technical expertise. Maybe you have somebody who's a software developer, but they don't really understand what data science is. And a lot of people who are in like marketing or whatever, data science just looks like magic to them. And so when you go to an interview, they don't necessarily know what to ask you or even what skill set they should be looking for. And they don't know what they should be asking you in order to figure out if you have the skill set that they need. So just keep this in mind. And I think companies, you can even tell people in the interview what they should be asking you, or you can tell them what you think their problems are. That's all okay to do. Like many people, question?
Are the small companies that you're?
I think the smallest company I interviewed at 2 companies, which were 3 people. Well, I'm not sure you could call them a company at that point. And anywhere up to about like 50 people, yeah. Okay, like many people, I don't actually care for recruiters that much. Let's just put it this way. I had a much more favorable impression of companies who used their technical staff to talk to me when I was interviewing. Recruiters, nobody really has any way to assess whether recruiters are doing their job, including the recruiters, so it's not entirely their fault. My hypothesis is that recruiters might have okay precision, so they find usually some decent candidates, but their recall is totally shitty. So they find like 5 decent candidates, but then they miss like 20 other awesome candidates. This is a hard problem. I don't really know what to do about it. I wish didn't have to be recruiters in the world, but obviously that's just not going to happen. So if I was working at a company or offering advice to a company, I think your best options for recruiting are if your existing staff know a knowledgeable recruiter who's treated them well in the past, those people are good options. And your technical interview should consist of, I'm actually perfectly happy to do like a day-long take-home problem. And I think that such a problem lets you actually give me something to work on that looks like the problem that you would like me to solve at your company. I think that's the best way to run a technical interview. Yula.
So, question for the audience. Are there any recruiters here? Question for you later, but also, are there any other people representing companies that are hiring data scientists? Maybe after a couple slides, I was wondering if you can come up and tell us how you're recruiting, what you're looking for, how do you screen, advice to complement what Kiri's talking about. Thanks.
Okay, yes. Thank you, Tavis. That was very helpful. Okay, so this is kind of an addendum to the talk, but I think Kaggleification has a lot to offer research, especially things like medical research. There's a lot of medical research that's like, we introduced technique X to solve problem Y. And usually these papers are super boring to read. And then usually it's really hard to actually take different techniques that different groups have come up with and compare them and actually figure out, was the problem that they solved the same and which solution is actually superior. And I think Kaggle provides a really good way to solve these kinds of problems. I think it also is a really good alternative to sort of the traditional, I have so and so many publications, so then I will be very awesome as a professor kind of approach to making a CV. If you can have this alternative option, which is, I did really well at this sort of Kaggle-fied problem, then that could be valuable for helping people identify individuals who have a lot of promise as researchers. I think another point is that when people work on a problem, they have a really good understanding of the problem, and puts them in a much better position to learn from other people's solutions. I think that's actually one of the most powerful things about Kaggle. And I think the other thing I really like about Kaggle is it helps keep knowledge and techniques public, and it helps disseminate information. Like Google has gone and hired all the top neural network researchers, and that information is sort of basically now all owned by Google. But by having Kaggle keeping this information and these ideas public, that helps to disseminate these ideas. So there's actually a couple of different organizations that are doing Kaggle-style competitions in biomedical research, Grand Challenges and Dream Challenges. I think I'm actually super excited about this. I think medical research is one of the areas where machine learning can have a lot of really amazing applications. But actually the biggest problem in medicine is collecting the data and disseminating it. And I don't know if any of you have been to the doctor here lately, but they're still giving out x-rays on CDs. And so actually doing a good job of databasing our medical information is, I think, the most important problem we need to solve. Okay, conclusion. Being unemployed is not a giant pit of despair. It helps when you have something to get you out of bed every day that you find interesting and motivating, and Kaggle did that for me. Kaggling is a good way to get better at attacking predictive modeling problems. Kaggle doesn't really help so much to get a job, but it did make me pretty awesome at my job now that I have one. Do-it-yourself training gives me a lot of freedom to learn whatever was interesting to me. But maybe a degree or an internship would have been sort of the faster, cheaper way to get a job. So if there's any other questions, I'm happy to take them now, and then I guess we'll go for a beer. Oh, somebody was going to say something about recruiting too. Yes. Do you guys want to have questions first or recruiting first?
Yeah. How about anyone who does have something to say, and you're towards the middle, come up to the mic right there. And there's also a mic on an empty chair somewhere. Someone can hold it up.
There's a mic over here, Travis.
There's a mic over there. So if you've got things to say or questions to ask, can you just migrate towards the mic?
Hi, I'm wondering if you've ever been in a team for one of these competitions, or have any advice for teams?
I have not actually ever been on a team. I have two friends who I've talked about joining a team with, but never actually did so. There was some complications involving which time zones we were in, and it was also Christmas, so that didn't transpire. Yeah, Kaggle lets you form teams as well. So you can work either alone or you can team up with I think 3 other people maybe. And then they have this algorithm for dividing the points up amongst you. Another question?
Yeah, I'm curious to what extent domain knowledge plays any role in these competitions. They cover a broad range of domains. Is it helpful if you have domain knowledge, or have they abstracted it away?
To be honest, in a lot of cases, people without domain knowledge win. It turns out that if you're just sort of semi-intelligent and you can deal with machine learning tools, you can make a lot of progress at the problems. I think where domain knowledge helps is actually formulating the problem. Because actually I think that's the hardest part of data science is what problem do we have to solve?
Quick question. Did you actually...
Oh, got it, okay.
I'm short, so. Did you actually, in Kaggle or even in the place that you work at right now, do you actually implement any of the algorithms from scratch, or do you just use the libraries that are out there?
Okay, so I'm not allowed to talk about what exactly happens at work.
Fair enough.
Okay, what I can say is that there are definitely things I learned Kaggling that I use every day at work. And it's even actually happened now that something I learned at work I'm using at Kaggle, which is kind of exciting.
Where are you working now?
Oh, I work at a company that does fraud detection, new data security.
Hi. So this is somewhat related to Kaggle, but also in general data science. How often do you have bad data, as in data that is not good enough to make decent predictions?
That's kind of a hard question to answer, actually. Well, I think definitely in real life, there's more bad data than there is on Kaggle. In Kaggle, they've really cleaned the data up quite a bit. Yeah, I definitely find myself using like fill in A in Pandas to figure out what to do with my missing data.
Okay, one other question. So you mentioned about there is no incentive to specifying uncertainties on your prediction. Did you mean for every single prediction?
So the score is you send in like the test data will consist of like 10,000 items that you're supposed to label, and the score is some function of I got this many correct and I got this many wrong. There's different ways that they evaluate. There's different metrics you can use to evaluate the problem. So the score is based on all the predictions that you make. So the only sort of statistical part of the prediction is that you have to try to choose which two submissions you want to use. So you can you can enter the competition like 50 times, but if you make 50 entries, you have to pick 2 submissions that you think are your best ones. And then the thing is that your best submissions on the final leaderboard may not necessarily be the ones that have done best on the private or the public leaderboard that's visible during the competition. Did that answer your question?
Yeah, sort of. I mean, I was wondering if you can assign some uncertainty to each of your predictions for
okay, so
model.
a lot of machine learning algorithms will spit out a probability. So if you have a classifier, it'll give you a probability that it thinks that's this class. And I think in a lot of cases, you can use that probability to decide whether or not you're confident about your prediction or not.
That's for classification?
That's for classification, yeah.
Okay. And in case you're trying to predict something, some numerical value?
I would have to think about that a little bit more, but that's a good question, yeah.
Thank you.
There's a mic coming to you behind you. No, you got it.
It's not on. Oh, yeah.
Yeah, it's on.
So I read there was this famous competition for Netflix, and I read that the winner algorithm was not actually implemented by the company because it turned out not very scalable. So because that happens because the reward is only on the accuracy but not on the speed. So I was wondering if that is very common for winners.
Okay, so I know of one other competition where that's happened. It was a whale detection challenge. So they had a bunch of whales going underwater, and they were listening to them with the microphones, and they were asking people to identify, which whale is it that's making the whittle whittle noises. And it turned out that in the end that the algorithm didn't work so well in practice. I do not remember why, though, actually, now. I can look that up afterward, though. But there definitely was that situation where it didn't work in the field so much. Any other questions?
Question about the mechanics of the process. What are you actually submitting at some sort of thing executable that they can run the data through?
Literally, it's just a CSV file with each prediction for each row in the test data. So when you're given the test data, for example, for the bot versus human competition, you have the test data. Each row is like account ID 1, account ID 25, account ID 26, and you have to make a prediction, which is account ID 1 is a bot, account ID is a bot, account ID is a human, account ID is a human.
And so anybody's source code and algorithm and so on, if it becomes known, it's because they put it on the forum or otherwise let it be known.
So a lot of people will share their code on, so I always shared my code on GitHub. And then there are some situations where the winner's code becomes the intellectual property of the company. So it's different. The rules are different for different competitions, though. But usually the idea is the company gets access to your code. A condition of receiving the prize is that you give them your code.
So when you're doing a competition, how do you distribute your time between things like exploratory analysis, feature engineering, and like model tuning and model selection?
I'm not sure I have a really good recipe for that. Yeah, when I'm doing stuff with neural networks, it just takes me a lot, because I'm not less familiar with that, it takes me a longer amount of time just to get something going that works. That's the best answer I think I can give.
So, guy in the back who's hiring, do you mind saying, there's a mic behind you.
Yeah, just got
hold on. Yeah, go.
So what I'm curious about is if your training set and your testing set are quite disjoint, and if you can set up an easy classifier to distinguish between them, do people end up trying to infer some of the predictables from the hidden test set? Is that a common strategy that people would do?
I'm not actually sure. That seems like an interesting idea, though. Yeah, that seems like an interesting idea.
Next time you run into it, come find me.
Okay.
Is it on? I was curious if when you're using methods, are you tuning them a lot, or are you finding that the defaults work fine for you?
Yeah, usually with random forest classifier, I don't have to fiddle with too much. If I use stochastic gradient descent, then I'll spend some more time to optimize the learning rates and the parameters. Okay. There's a tool in Python in sklearn called grid search that'll let you go through and sort out which of the settings are the most optimal.
Sorry, 1 second. Go ahead.
Hi, yeah, so you expressed enthusiasm for neural networks, and you said that you've been reading about them. Have you found that understanding the inner workings of that algorithm has translated to better success with them?
Okay, so to be honest, the biggest challenge that I have with neural networks is that I don't understand how best to go about selecting the geometry. And I don't actually think anybody else does either, because I've looked and it's not well described on the internet somewhere convenient. I was working mostly with feed-forward neural networks, but I've been trying to learn a little bit more about long short-term memory networks. And all these different networks have different architectures and different kinds of operations that happen at each node. Mostly, I just really find it interesting to learn how they work, too. And then, I don't know, the other part of the problem is that to get them trained, you have to have a huge amount of data. And then this kind of comes into the Amazon Web Services thing. Because if you have an Amazon Web Services account, you can put a huge amount of data and run and rent a GPU and then train your algorithm with the GPU. But yeah, I'd like to understand them better than I do.